Hi, my name is Riki Fridrich. I will try to share my screen. I am a JavaScript developer. I've been doing for a long time now. I work at Outreach. I write JavaScript there. We are hiring. It's a great company. Try to check it out. And today I'm here to talk about asynchronous code. And you may think, what do you want to say about asynchronous code? We have async await syntax, and that's it. That's the best thing ever. Well, yes, but actually, no. I will show you how we got to the async await syntax. I will try to convince you that async await syntax is not the best way to write asynchronous code. And I will show you what you can do with promises, and we will try together to write some simple implementation of something like promises, so that you will not think that promises are magic. I hope it will work. Why am I talking about asynchronous code? I write JavaScript, I have been writing JavaScript for a very long time, and I went through all of these stages, through callbacks and promises and async await. So I know how we got here, what problems are we trying to solve. But when I'm speaking with developers who started lately, they often only see the current syntax that is used, and they do not understand how we got here and how to do it correctly, how to use the full power of all the tools they have available. Okay, so first a little bit of history. There were callbacks. At the beginning, there were callbacks. When we wanted to write some asynchronous code, we could no longer use functions with return statements because, if we want to execute something later, return statements are not the way. So there was a simple way to do that. We just used callbacks. Callbacks are functions like this that you provide as a parameter into some other function, and when that function is ready to execute some code sometime later, it will execute this callback function and put some data into it. So this is a practical example of this. This is from Node.js. It's a simple script that reads content of this file. There are some options, and there's this function. We will receive the file content when it is ready in this parameter, file content, and we will print it out into the console log. So this is the content of the file. It clearly works. Okay, so why don't we use this pattern still today? Check this out. Here is the underscore. There is something that I'm hiding from you. It's the error object. In the early days, it was really, really, really hard to debug callbacks in the code because the anonymous functions, the callbacks, were executed, in outside of normal call stack. So it was really hard to debug the code. So you needed to pass errors, if there were any, and to handle them immediately. So there is a convention that the first parameter of the callback is always error object. It's either there, if there is an error, or there is, null, if there is no error, and then there is some value. So the full code of this example will look like this. We will check if there is an error, handle the error. If not, we will handle the success case. And this looks nice. This is pretty fine until you try to do more things in a sequence. So this is an example of me reading single file, second file, then joining their content, and then writing it into a third file. We are nesting 3 callbacks into each other, and you can already see that there is this pyramid of doom. It's called callback hell. And this, to be honest, is a very simple example. In reality, you could easily have like 20 levels of nesting. You will need 2 widescreen monitors to see the end of the line sometimes. So this was a horrible pattern. But it worked, and that was the first step in the evolution of the async code. So these are callbacks. OK, developers wanted to get rid of this. We wanted to get rid of the callback hell, of the nesting, and we wanted to handle errors in a more sane way. So promises appeared. These are promises. This is exactly the same example as before. It's just using promises API, file system API in Node.js. These days, you can use promises in Node natively everywhere. It was not, historically, it was not always the case. So how does it look? You have this function, file system read file. It reads the file. You provide some attributes. That's the same as before. But there is this then method, which contains some function, and you will receive the file content into this function, and you can print it out. OK, fine. But how do we prevent nesting, and how do we handle errors? So let's see. We handle errors by chaining. Do you know chaining? Do you remember jQuery? jQuery uses chaining. OK, so we can chain this then method. We can call catch. And if there is an error, it will receive some error. It will be called, and we can do something about this. So this is promises, and we have replaced the callback hell with promises. Ta-da! That's done. No, I'm just kidding. This is Robin. Robin is losing consciousness when he sees this. Yeah, this is just one by one, rewrote of this callback hell code. Actually, you can do something like this. So in this example, I needed to create some utility function that just takes some provided content, some string, some file path. It reads the content of the file, joins these contents, and returns the promise that does this. And with this, we can, oh, there are some pop-ups. With this, we can chain the whole thing like this. So the promise is so-called thenable. So it has a method then, which you can chain indefinitely. You can call then, pass some values and some promises down the chain. When you are ready to display the result, you do that. And if there is any error anywhere in this promise chain, you catch it, in the last statement, and you handle it in one place. So this, linear chaining code with catching errors at the end replaced the callback hell, and everything was fine for some time. OK, so on our evolution chart, promises are the second step. They are a little bit more involved. But the problem is JavaScript developers, poor guys, they looked at promises and saw some alien syntax. They didn't understand how it works. So they were like, oh, we want a better syntax. What syntax? Something that looks like synchronous code. OK, so in ECMAScript, they came up with async await code. It's just 2 new keywords, async and await. When you define a function, you can put async keyword in front of it. And if you are calling this async function, you just put await in front of it. Otherwise, it looks like a synchronous code. OK, so this works. If I will run it, you can see the content of the file. Perfect. Looks fine. How do we handle errors? We just use try-catch. We use the native syntax, JavaScript native syntax. You just wrap everything you need into a try block. You catch errors in single place. It does exactly the same as the promises, just with more native syntax. And of course, you can kind of chain, if you need to load 2 files, so you can await loading of the first file and await loading of the second file. and then you await execution of the write function. And that's it. That's the chaining. It looks really nice, really neat, looks like native JavaScript, no magic included. OK, so let's update our evolution chart. There it is. Callbacks, then promises, then async await. It's fine, right? Well, it's not. Let me get back to this. Why is nobody screaming at me? This is wrong. This is completely wrong. This is not how you use promises. Like, can you see the problem? Why are we waiting until the first file is loaded and then try to load the second file? Why are we doing this in sequence? We can do that, in parallel. We can load the files at once. Come on, people, wake up, scream at me. Robin, I expected more from you. No. I knew he will catch it, and I told him to shut the fuck up. So. OK, so how do we do that? We use promise all. Promise all can receive an array of promises, and they are executed in parallel. So we load the files at once, and then we join them and write them down, and then we display something in console, or we catch error if there are any. So, ta-da! This is the power of promises. Promises have methods that are not available to async await syntax. I already showed you promise all. This is great. This is something that you will be using the most. It just executes several promises at once, in parallel. And it returns promise that will receive an array of, I can show it. It will receive an array of all the resolved values from all these promises. The thing is, if any of these promises will fail, then all the results will be lost, and we will skip directly to the catch method. OK, what are the other useful and handy methods? This is promise any. I just mentioned that if in promise all there are any errors in any of the problems, any of the promises, it goes directly to the catch. Promise any is a little bit different. It executes all of these promises, and it resolves the first one that is successful. So here I have some delay function. So after 1 second, we should receive a success. So 1 second, OK, it's successful because the fast one was resolved. If I will put 3 seconds here, then the failure should kick in 2 seconds, right? But, OK, instead, this 3 seconds success promise kicked in. Why? Because errors are ignored. If there is any successful promise in this array, then all the errors will be ignored. Okay, so that's handy sometimes. There are some special cases with any. Like, why should we write the catch method for any if all the errors are ignored? Well, they are not ignored, but if there are only errors, they are code. Like, if there is no success, there is an error. So we can see it's here. And also, if you do not provide any promises into this, you will again get an error. So promise any. If there are any successful promises, it will be fine. It will succeed. But if there are no promises or only error promises, it will fail. Fine. There's another handy method. It's called promise raise. And it's really similar to promise any, but it handles successes and errors. Whatever comes first. It doesn't really matter. So if I will run it this way, after 1 second we get a success. And if I will set 3 seconds here, after 2 seconds we should get a failure. OK, yes, it is. This is handy, for example, in UI, where you want to display some UI like, OK, load the content of this file or request this information. And you can use promise race to create UI that will wait, I don't know, 5 seconds, and then it will fail and display UI that will say, oh, this request is taking too long, try again, or something like that. It's really promise race is really handy for these kind of situations. There is one catch that you should be aware of. If you do not provide any promises into promise race, it will just run forever. It will never resolve. There will be no error. It will just, it will never be fulfilled. So be aware of that. OK, and the last very useful method is all settled. And this, personally, is my favorite. It runs all of the provided promises, and whatever they return, whether they are successful or not, they will return all the results. So in this case, we have received an array which contains, first item is successful, second item is an error, third item is, again, successful. And there is a little bit of change from all of the previous methods. They always resolved into an error or some resolved value. This one has to differentiate between successes and failures, so it returns an object that has property status, which can be fulfilled or rejected. And if it is fulfilled, it will have property value. And if it is rejected, it will have property reason, which will contain the error object. So this is, I think this is really handy. Where do we have it? OK. So for example, let's say you have a system where users can create objects, do something with the objects, and then they can destroy the objects. Like, I don't know, create files, write into files, and then they can delete the files. And you want to create something that will do like batch operation over these objects. So we will select several objects. You will get a list of them, like this list of files. And you want to run some batch operation. Or the user wants to click on something and, I don't know, rewrite all of these. But meanwhile, some other user deleted some of the files. So you can, and it will be shame to fail the batch operation just because there is one object that resolves into an error. So you can do something like this. You can run all the promises and filter out all the errors. Like, we receive this array of resolved promises. We filter the ones that have status fulfilled, or we keep only the ones that have status fulfilled, and then we just display the values. So in this case, we will get the content of the 2 files, and the third file will be ignored. And if we will complicate it a little bit, we can add a little piece of code that will, again, filter the files, keep only the ones that are rejected, and then get from the reason object the path of this file. So if I will run this, I will get the content of the files that were successful and the list of the files that are not successful. This is really handy. OK, so I hope I have convinced you that the promises are really great, so we can update our evolution chart. Like promises are like Iron Man. They can do anything. They can fly up and down and fight the enemies. Yeah. Also, async await syntax has its limitation. It's intuitive. It's really short. It's concise. But you can't do everything with async await syntax. Like, for example, you cannot write a delay function using some set timeout, because async await syntax, it just does not support any case like this. So it's not good for all these situations. So let's update our evolution chart and downgrade our async await into some person that identifies as someone who uses a wheelchair. OK, now, How do the promises work? When I speak with developers, especially the junior ones, they are always confused by their syntax. And it looks like a magic. You have some object that runs some things, and you can call then. You can provide values, or you can provide promises into them, and the then can go on and on and on. Even if you just provide values, it's really strange. And the errors, how come the errors don't come up on all of these then methods? How come that the errors fall at the end into the catch? So yeah, here's how promises work. You just create them. You will provide some function that has resolve or resolve and reject properties, which is just a function, just kind of callback. If you will call it, it will go to the next then. If you will call reject, I will show it in a minute, it will go to the catch. You cannot parameterize the promises. This is the only parameter that you can insert into promises. Its arity is 1, so you only can provide this function. So here in this example, I want to add 2 values, so I had to put this value into a constant. I cannot parameterize the promise. So the usual thing that you do is you just wrap the promise in a function, you provide some value as a parameter of the function, and then you return the promise. Okay, so instead of just directly calling the promise then, you call the function with the parameter, and that returns promise, and then you call then. Okay, here is the error handling. You provide resolve and reject functions, and depending of what, depending of whether it is success or failure, you just call resolve or reject, and this way you get the then and the catch methods. So for example, here I'm providing a wrong type of value, so I go directly to the catch and say value must be a number. Okay, so yeah, and I was mentioning this, you can pass just simple values as a return value of the then functions, and the then chain still works. Like, how is it possible? And also, I can pass another promise functions, and they go on and on and on. Like, there is no difference between regular values and promise values. It's kind of strange. So let's try to do some simple implementation of something like promise. Let's call it something, to be really precise. Okay, so this is our something method. What does it do? We provide, this is a function, we will provide some value, and it will return an object. And this object has method, it's called next, it's equivalent to promises then. And it's a function that will receive a parameter that should be a function, and it will call the function and provide the value into it. So yeah, it's kind of complicated at the first sight, but this allows us to do something like this. We will create a variable named user by calling the something function and providing the value Riki Fridrich. Okay? And then this something value has a next method, so we can call user.next, and we provide some function. And the something object will pass the value into this function, so the result will be Riki Fridrich in the console. Okay, so this is the basics of promises syntax, but it kind of does not do anything, and there is no chaining and nothing like that. We have to make it a little bit more complicated. Okay, so let's do this simple thing. When we execute the function and provide the value into it, we will take the result and wrap it in something. So we create something, and when we call next, what we return, we will wrap into something again. what did we achieve now? What does it do? Well, it allows the chaining. So now I can chain this. I have created the user. It has a next method. And the next method returns something. OK, so I will provide the first function. It will just split the content at the space. And it will return something object, which has next method. So we will call this next method, and we will provide another function which will do something with the result. In this case, it will reverse the result. So we will have array of Fridrich, Riki. It will be reversed. And again, this next method returns something. So we can call next method, and we will provide another function. This one just joins the array with the comma, so we will get Fridrich, Riki. If I will run this, yeah, it kind of works. It returned Fridrich, Riki. So now it already looks and kind of works like promises. We already have this like endless ability to chain the next method, one after each other. Let's do some house cleaning. I just took these functions from here. I call them split, flip, and stitch. Try to say it 3 times in a row, and you will win the prize. And I just moved them up here, just to make a code a little bit concise. And now we will create the next object. And since we already have something, now we will create nothing. And nothing will look exactly like something, but it does not expect any value. It does nothing, so why bother? And it does not expect any function, so we just return nothing. So now we can chain nothing, next, it will return nothing, so next will return nothing, next will return nothing. Fine. What will happen, or why is the nothing object so useful? If we will create a user using the nothing function, it will do nothing, but it will not throw any error or anything. The chaining will still work, but nothing will happen. If I will run this, you see the console, it's empty. There is nothing. But the syntax is the same. We can still call the next, however many times we want. OK, so we are getting somewhere. What are we going to do with this nothing? Well, first, we will create some function. I call it getUser. And it checks, it receives a name. And it checks if this name is a string, it will return something. If the name is not string, it will return nothing. And there will be some error message, like the name must be a string. OK, so if I will pass a string value into this, it will go through the whole chain and print out Fridrich, Riki. So it works. If it's something, then it works. Now I will provide, I don't know, 1, 2, 3. Or what's the name of Elon Musk's kid? That will also be not a string. OK, let's run this. Nothing happened. You see? But there is no error. It's nothing. Syntax is still the same. Input is different. And it just works. So now the only thing that we need to do is to catch the error at the end. And how do we do that? Well, we add to our something and nothing object another method, which will be called catch. And we will kind of flip it like a mirror. In something, the catch method will do nothing. Because if the chain is successful, if we will call catch, we don't want it to do anything. Okay? So catch in something will do nothing. That's a strange sentence, but it's factually fine. Okay, and the opposite way, nothing will receive an error. And if we will call the catch, it will do exactly the same thing as something, except it will wrap it at nothing. Okay, so now we can, anywhere in this chain of next, we can call catch. And if there is an error in anywhere, Or if we are working with the nothing object, it will be printed into console log. Okay, so let's try it. Normal name goes through. And if we will pass 1, 2, 3, or Elon's son, name must be a string. Okay, so we are almost there, almost. Just little bit. What do we need? If you look at this code, the only place where we can create either something or nothing is this one, this first function, getUser. We cannot create nothing in the middle of the chain. We can do it only, or currently only, at the beginning of the chain. So let's create a helper function which I call isEither. I don't care if it is something or nothing, it will return true. Like, you know, I'm just detecting if the object that I have received is either something or nothing. So I'm checking if the value exists and if it has next or catch methods. And I use it like this. Here it is. In something next method, I first try to evaluate what will be the return value of this method. I call it next value. And then I check whether this next value is either something or nothing. If it is either something or nothing, I just return this value. I don't need to wrap it in anything else. But if it is not, if it's just any other kind of value, I wrap it in something. So now I have a chain that will always work with something or nothing. And of course, I do exactly the same, just mirrored out in the nothing object. So what it means, what does it mean? I can update these three functions, or some of them, so that they can have either success or fail state. And it looks like this. So the split function, it splits the value into chunks. If there are less than 2 chunks, like if somebody has only a single word name, like Madonna, or I don't know, Maradona, then it returns nothing with the error message name has to have at least 2 parts. Otherwise, it will return something with the list of the chunks. And in the flip method, we do like the opposite of this. We check the length of the values. We already split it. And if there are more than 2, then it's somebody who has really long name and maybe some lordship title or something like that. So then we will return nothing with the error message name is too long. Otherwise, we return reversed value in something object. So let's see. We have everything else is the same. If we will run it like this with Riki Fridrich, we will receive Friedrich, Riki. So all the successes work. If I will say that my name is Madonna, and if I will run it, it will fall into the first nothing that we can receive, and it will say name has to have at least 2 parts. If my name is Jean-Claude Van Damme, do you remember the karate films from your childhood? Or am I the only old one? Yeah, he was a really cool guy, but his name is too long. Sorry, Jean-Claude. Okay, so we have created something like promises, and this is to demonstrate how you can create an object that you can endlessly chain with next method, or in promises it's then, and at the end you can call catch, and if there is an error anywhere in this chain, you will handle the error. If there is no error, then the catch is ignored. So this is how promises work. If you have ever thought that monads is something really complicated that you will never understand, and you at least a little bit understand what's going on here, well, congratulations, now you understand monads. This is exactly what monads are. If you are interested in monads in more detail, Robin will have excellent presentation right after me, and he will explain it much better and with more visual clues. So stay in. Okay, so this is how promises work. But again, promises are not, are not perfect. So, for example, if I have this delay function, and this is exactly the same as I was showing before, it just has some debugging messages inserted here. So, if I will call delay, I don't know, 1, and I will run it, it will display that it is starting, and then it will display that it is done. Okay? Is it clear what it does? Fine, because now I'm going to run a list of promises of these delays in a loop. Like, for example, I have a list of some URLs, and I want to check all of them, but I want to check them sequentially. Like, I don't want to overload the server or something like that. I want to check them in sequence. So, yeah, I will create a loop, go through all the URLs, I will call them, but what will happen? Watch. All of these, well, were started at once, and their execution started at the same point. So this is not what I wanted. Well, how can I do it with promises? Of course, I can use the chaining. I can write it like this. If I will run it, then the first starts, then the second one starts, and when it ends, the third one starts, and it works fine. But look at this code. Good luck trying to generate this, in a loop. So yeah, it's easy to write this by hand, but you cannot generate this in the loop. Well, do you remember async await syntax? Let's call async await to the rescue. If I will use this, it works exactly as I expected inside this loop. And that's because the async await syntax, it stops all the execution, or it is written so that it kind of stops all of the execution of the code at the moment when there is await, and only continues after this await is resolved or rejected. So async await is a great syntax for simple stuff. It's very intuitive, but because of this simplicity, it cannot handle some more complex situations like the promises do. So let's be fair. Let's update our evolution chart and make the async await. Okay, and since promises are not, all powerful, it's still an Iron Man, but it's Mark I version. It will still kill the enemies, but it's not the shiny Mark 42. And yeah, one last thing. Let's check it out. What does the async function return? What is it hiding? I was saying at the beginning, the async function is just a syntactic sugar that hides the promises. So if I will run this, you can see both of them return a promise. So the async await is actually promises just hidden. And let's check out what the promises are. Like, what is this? What is this resolve? It's a function that I pass into some object, and it is called later. It's callback. So promises are just, monads, mumbo-jumbo, hiding good old-fashioned callbacks. So let's update our evolution chart for the last time. It was always the callbacks. They are just hidden in armor and in wheelchair. Okay, that's it from me. Thank you. I hope you have learned something. Yeah, thanks.